Well, howdy, y'all. Welcome to another one of my aviation weather videos. So in this video, I'm going to be talking about saturation, relative humidity. Now, this is one of those topics that, I feel like a lot of my students at the university, they don't quite understand at the beginning this topic. So I'm just going to break it down to you nice and simple so that you can really understand it. So I'm Dr. Andy Moltar. I'm a CFI, double I, MEI. I used to be a corporate pilot. Now I'm a professor of aviation. And so saturation, that is the maximum possible quantity of water vapor that an air parcel can hold at any given temperature and pressure. And I want to make that very clear. So based on the temperature of the weather or of the air, that will determine how much moisture the air can hold. So if it's hotter, the air can hold more moisture, whereas if it's colder, then the air can hold less moisture. And so we use the term saturated and unsaturated. So unsaturated just means that the air can hold more water vapor. But once it reaches that 100% saturation point, we call it saturated. That means the air cannot hold any more water vapor. And so if it can't hold any more water vapor, then the moisture will become visible in the form of fog clouds, um, and then so that's what saturated air is. And then we use the term relative humidity. So anytime anybody uses the word humidity, what they really mean is relative humidity. So relative humidity is just a ratio. And so it's the ratio of how much moisture the air could hold versus how much is actually present. So here's an example of two separate air parcels. So I want to make it very clear, these are two separate air parcels. One of these air parcels is 40 degrees Celsius in temperature, and then the other one is 10 degrees Celsius in temperature. So the actual amount of air is the same, but as air warms up, it increases it expands. So as it heats up, the air expands and it takes up more space. That more space allows for more potential of containing water vapor. And so in this 10-degree Celsius air parcel, then, let's say that it has a certain amount of water vapor inside of it. And this ratio, this relative humidity, is 30%. But we look at this different air parcel that's 40 degrees Celsius, it takes up more space and it can hold more moisture. The amount of moisture held in this air parcel just happens to also be 30% relative humidity. Now, when we compare the two air parcels, the air parcel that's 40 degrees Celsius has a lot more water vapor than the smaller air parcel. And so, even though the ratio is the same, the actual amount of water vapor is more when it's 40 degrees Celsius when it's the same relative humidity ratio. So if you ever wonder, like, hey, when it's winter time, it's cold outside, and your lips are dry or your skin's dry, and you look at your weather app and it says 30% humidity, you're like, man, it doesn't feel like it. But it's because it's colder, the air can hold less moisture than when it's warmer. So that's why you feel the humidity more in the summertime when it's hotter, even though maybe the ratio, the amount of relative humidity isn't that high, you can still feel it because it's warmer. There is, in fact, more moisture in the air. So here's another picture we have for you. So in this picture, it's the same amount of space, but the temperature changes. And these light and dark green dots represent, how much moisture could be in the air. And so the light dots are, potential grams of water vapor, whereas the dark green dots are actual grams of water vapor. So when it's 30 degrees Celsius, here on the left side, uh, we see that there's, 8 grams of water vapor, but there's a lot more potential water vapor capacity in this 30 degrees Celsius air parcel. But as this air parcel decreases in temperature to 20 degrees Celsius, then the potential, grams of water vapor decreases. Now, the actual amount of water vapor in that air parcel remains the same. So here on the left, we had 8 grams of water. But then as we go in the center here where it's 20 degrees Celsius, it's still 20 degrees, or it's still 8 grams of actual water vapor, but the capacity of that air parcel is now less because it's colder. And so, whereas on the left side here, it was 8 grams versus the capacity for 27 grams, now it's 30% saturation or relative humidity. So here in the center, then it's still 8 grams of water. And so 8 grams with a capacity of 15 grams, now it's 53%. And then this air parcel on the right cooled down to 10 degrees Celsius, and its capacity for water vapor is 8 grams, and that's still exactly how many grams of water vapor that exist in that air parcel. It is now 100% saturated. And so another term we want to know is dew point. So we know what temperature is. We measure it with a thermometer. It's a random number that we assign to the, for the amount of heat in the air. Well, dew point is the temperature of an air parcel that represents at what lowest temperature must the air be cooled for the air to be saturated. And so if the temperature decreases to its dew point, then the air will be considered saturated, 100% relative humidity. When that happens, when the dew point is above freezing, then the water vapor condenses into dew. But, so you walk outside in the morning and there's like little beads of water on the grass or leaves, that's dew. But if the dew point is below freezing, then the water vapor will condense into frost. All right, so here we have a term, it's called dew point depression. So this is the difference between an air parcel's temperature and its dew point. Now we more commonly refer to this dew point depression as a temperature dew point spread. All right, so sometimes you'll hear, temperature dew point spread. This is what we're referring to. So METARs and species. Specie is just a METAR, but not issued hourly like a METAR. But METARs and species, they provide both temperature and dew point. And by looking at what the temperature is versus what the dew point is, we can kind of gauge what the spread between them, how close we are to saturation. And so when the temperature is the same as the dew point, we would say that the temperature dew point spread is 0 and that the air is 100% saturated, means 100% relative humidity. And so when it is 100% relative humidity, we can expect low-level clouds, surface fog. And one thing I want to make clear is that even though the air can be 100% relative humidity, it does not indicate any possibility of rain or snow or anything like that. It's just an indication of what the relative humidity is. All right, and then here's just another picture kind of showing the relationship between temperature and dew point. So here on the left, you see that the temperature is 22 degrees Celsius, but the dew point, this green line that goes all across all three of them, is 11 degrees. And so, and right now, the dark green is the actual water vapor, and the lighter green is the possible water vapor for this air parcel. Now, as that temperature decreases, as we see in the center, it gets closer to the dew point. Now it's the same amount of water vapor, but the possible water vapor area decreases. And then as the temperature keeps on decreasing and it reaches the dew point, now that this is the maximum amount of water vapor that can be contained in this air parcel, we would say that this is 100% saturated, 100% relative humidity. All right, well, that's it for this video. If you have any questions, leave them in the comment section. I'll be happy to answer them. Hope you all enjoyed this video. Please like and subscribe. Y'all take care. I'll see you in the next video where we talk about the change of phase of water vapor. So, all right, y'all take care. Bye.